This is the sum of a finite geometric series. There are infinite geometric series if the ratio is less than 1. Instead of getting bigger and bigger and bigger, the ratio converges on a number, and we'll learn that later. But right now, this is the sum of the finite geometric series. So first thing we got to do is get our formula out. And it looks like this. The sum of a finite geometric series is the first term times 1 minus r. That's the common ratio. And then n is the number of terms you're trying to sum. So that's what we got to figure out. I'm going to erase that stuff there, and we'll go back over here. So here we have this thing right here. There's our formula right there. Oops. Let me get that going here. Here's our formula. And then here's our sum, our sigma notation. So this says right here, it goes from 1 to 5. There's the 5 right there. So the number of terms we're summing is going to be 5. The R value, I'm going to erase this stuff now. The R value is whatever number is under the exponent, because it's the thing that's getting multiplied a certain number of times together, right? So here the R value is 4. So R equals 4. And then we're going to find the A value. What's the value of the first term? So this is our formula right there. This whole thing, right? So A1, we're just going to use that 1 as our n to find the first term. It's going to equal 4 times, and we'll put a 1 where the n was. 1 minus 1 is 4 to the 0, and anything to the 0 is, don't say 0, I'll yell at you, 1. Anything to the 0 power, 4 to the 0 power is 1. All right, so now we have everything we need. And we can go back and start with here. We got to write our formula. So the sum of a certain number of terms equals the first term times, and it's a fraction, right? And the top one is 1 minus r to the n. And the bottom is just 1 minus r. And let's go back and double check that to make sure we got it right. Never hurts to double check. We got it right, so we're going to keep moving. All right. So we know our A1. We can just crank this thing out. And I'm going to pause this. All right, I'm back. I hope that pause worked properly. So our A1 term is just 1. I'm going to put it in there so you can see it. And then we have 1 minus, and what's our R? R is going to be 4. And the number of terms from n from 1 to 5. So that's 5. 4 to the 5th, and you know that's going to get to be a pretty big number, over 1 minus R. R is 4. All right? So now we're just going to come down here, and we're going to say 1 minus, and now we have to get out our calculator. 4 to the 5th power equals 1,024 over 1 minus 4. So that's going to equal negative 1,023 over negative 3, right? So we'll do that little problem. And that comes out to 341. And now we're going to put that in the blank, and hopefully it won't be an embarrassing teacher moment. 3, 4, 1. Bam. Hey, it's not an embarrassing teacher moment. Let's do one more, okay? Let's slide that up. All right, and actually, look at that. I can erase the other stuff. and leave the formula. Although I wish it had, it's definitely not as sophisticated as our regular whiteboard, because I could draw a square and erase that. But we're almost done, and I'll just keep talking until I'm done. Hopefully that'll keep you entertained. I'll just keep talking you to sleep. Good night. Everything's okay. All right, here we go. All right, so let's get a different color here. How about that color right there? All right, so we got to find what's our n. Again, that's the number of terms we're summing. So that's 5 right there. Now, sometimes this is n starts at 0. So if it's 0 to 5, that'd be 6. And if it starts at -1, that would be 7. And just think of a number line, right? If you got -1, 0, and then 1, 2, 3, 4, 5. Those are the terms, right? So that's term 1, term 2, term 3, term 4, term 5, term 6, and term 7. So just watch that, okay? Just watch that a little bit while you're doing stuff, because it's not, you can't just look at the top number. That's what I'm saying. You can't just look at the top number, okay? So in this case, n equals 1, so we can actually just take that top number. Now, the next thing we're looking at our formula, we're going to need an r. What's our common ratio? Well, it's whatever's under the exponent, right? And in this case, it's 4. So we have a common ratio of 4. And the last thing we need is our first term. So our formula is 3 times 4 to the n minus 1. And since we're putting in the first term, we're going to put in 1. That's where the n is, right? In the formula. 1 minus 1. And then we just got to do that math. 1 minus 1, that equals 0, right? So 4 to the 0 is what? It's not 0, it's 1. So our first term is 3. All right? Hope you're with me there. Let's just get rid of that. And the last thing to do is kind of just go for it here. So the sum of the first 5 terms is our first term, 3 times 1 minus our common ratio, which is 4 to the n power, that's the number of terms we're summing, over 1 minus r, our common ratio, which is 4. So that's going to equal 3 times 1 minus 4 to the 5th power. That was 1,024, wasn't it? I'm not going to trust my memory. I don't trust my memory for anything. But it was. I was right. 1,024 over 1 minus 4. So that's going to give us 3 times negative 1,023 over negative 3. And we're very near the same thing, aren't we? 1,023 divided by 3, that's 341. So now we're going to have equals 3 times 341 equals what? 1,023 again, of course. We just divided, and now we're back up there again. All right. So let's put that number in and see if we have an embarrassing teacher moment or not. 1,023. Yes, I did it right. Okay, good. So they've just got one more here, and I want to I'm going to clear the whole thing because it's too hard to do. So this is a series that, because notice, I'm just going to point this out to you real quick, right there. That is actually less than 1, right? So as this exponent gets bigger, this number is actually going to get smaller, right? Because if you take it to the second power, 2 times 3 times 2 times 3 equals 4 over 9. which is less, right? Times, and then you add another, you put another instance of the common ratio in there, right? 2 times 3, that's going to equal 4 times 2 is 8, 3 times 9 is 27. So you can see that this one actually gets smaller with every iteration of the thing. So point that out to you. You still do it exactly the same way. And then notice here, our n starts at 0 instead of 1. So you have to take that into account. And again, still, we're going to put a 0 in when we're trying to find A1, right? Which means that this is going to be 1. So our A1 is going to equal 2. And I think that video is long enough, and I'm going to let it go and hope that helps. Bye-bye.